This discussion is only good for right triangles. There's other types of trig we'll talk about later. Since the Pythagorean theorem kind of locks in the relationship between the three sides of a right triangle, let's see what happens when we start dividing two of the sides and coming up with a decimal. That decimal could be used in other triangles, other right triangles that have the same angles. So for example here, I'm going to take a look at our friend the 30, 60, 90. 30, 60, 90 had this property that the smallest leg times 2 would give us the hypotenuse. That was an important property. The smallest leg times 2 gave us the hypotenuse, and the smallest leg times radical 3 gave us the other leg. So let's just take a particular one, like 5 for the small leg, that would make twice that 10, and 5 radical 3 would then be the other leg. So I'm going to focus on this 30-degree angle, and I'm going to mark up the triangle with different names. So if the 30-degree angle is situated here and I stand at angle A, let's call it angle A, and I spread my arms out, I will look directly across at this 5, so I'm going to call that the opposite, because that's what's directly opposite A. The hypotenuse is already locked in because it's opposite the right angle, so what's left has to be the adjacent side to angle A. So we have three names: hypotenuse, opposite side, adjacent side. If I form these three fractions, opposite divided by hypotenuse, adjacent divided by hypotenuse, opposite divided by adjacent, the mathematicians have come up with names for these decimal answers. They are called the sine, the cosine, and the tangent. And the mnemonic to remember them: SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. You can see them here in these fractions. So if I perform the division, so opposite divided by hypotenuse would be 5 divided by 10. Adjacent divided by hypotenuse would be 5 radical 3, but that has a decimal answer. So 5 radical 3 divided by 10. And the tangent would be the opposite divided by the adjacent. So when you do that, you get these decimals: 0.5, 0.866025, and 0.57735. They are stored in the calculator in the buttons sine 30, cosine 30, and tangent 30. We can use them later in other right triangles that have a 30, 60, and 90 triangle. Now, this must work for other triangles. So if we take a triangle that was, let's say, 35 degrees and 55 degrees and 90, we should also be able to form these decimals.